You leave for work. You close the door behind you. You assume your dog goes to sleep. Your cat goes back to the window. Your horse forgets you exist until you come home tonight. Roughly 14 to 29% of dogs in modern homes show measurable signs of separation anxiety, and a dog's cortisol level begins rising within minutes of its owner walking out the door. Cats withdraw. Horses pace. Some animals lose weight. Others stand at the same spot near the door for hours, watching the place you last were. But for 99% of human history, this didn't exist. No commutes, no 9 to 5, no long absences, no closed doors between animals and the humans they loved. For 200,000 years, humans and their animals lived together every day, all day, for hundreds of generations. So when you walk out, what actually happens inside their head? Do they miss you? Do they wait? Or do you simply vanish from their world the moment the door closes? The answer is more chemical, more enduring, and more heartbreaking than most people imagine. Let's start with what your dog's body is doing right now. In 2011, the Swedish ethologists Therese Wren and Linda Keeling at the Swedish University of Agricultural Sciences published a study in the journal Applied Animal Behavior Science. They took 12 domestic dogs, none of which had been diagnosed with separation anxiety, and filmed them while they were left alone in their own homes. Each dog was left for 30 minutes, then on a separate day for 2 hours, and on a third day for 4 hours. The researchers also measured cortisol in the dog's saliva and tracked their heart rates. The numbers told a clear story. The moment the owner walked out, the cortisol began to rise. The heart rate climbed and stayed climbed. And here was the part nobody wanted to read. The dogs did not adapt. Their stress hormones stayed elevated for the entire separation. 30 minutes, 2 hours, 4 hours. The body of the dog stayed in a state of waiting. There is no version of your absence that your dog learns to relax into. Every time you close the door, their chemistry locks into the same anxious holding pattern and stays there until you come back. Other studies have since shown that even the sound of you picking up your keys is enough to spike the dog's heart rate. The dog has cataloged the small noises that precede the absence and reacts to them before the door has even opened. But sometimes the door closes and the human does not come back. In Tokyo, in the spring of 1924, a professor of agriculture at Tokyo Imperial University named Hidesaburo Ueno brought home a brown Akita puppy. He named him Hachiko. Every day, Ueno took the train from Shibuya Station to work. Every evening, Hachiko walked to the station to wait for him to come home. They did this together for a year and a half. Then, on May 21st, 1925, Ueno suffered a cerebral hemorrhage in the middle of a lecture. He died at the university and never returned to Shibuya. That same evening, Hachiko went to the station, as he always did, and waited. The next day, he went again. He kept going every day for the rest of his life. For 9 years, 9 months, and 15 days, Hachiko walked to Shibuya Station and waited for a man who could never come back. Commuters started bringing him food. The newspapers wrote about him. He died on March 8th, 1935, after one final wait. A statue now stands at the spot where he sat for almost a decade. 3,558 days of waiting for someone who is already gone. No human in the history of the world has ever been waited for the way Hachiko waited for the man who could not come back. And it is not only dogs. In 1972, the American zoologist Cynthia Moss arrived in Amboseli National Park in southern Kenya to study elephants. 53 years later, she is still there. Her project is the longest continuous study of any wild mammal in history. Over those decades, Moss and her colleagues documented something nobody had quite believed before. Elephants grieve. When a member of their family dies, the rest of the herd stops moving. They gather around the body. They touch it with their trunks. They cover it with branches. They return to the bones months later and stand silently around them. In 2005, the British biologist Karen McComb at the University of Sussex, working with Moss, ran a controlled experiment. She placed elephant skulls and ivory next to skulls of buffalo and other species. Then introduce the items to wild elephant families. The elephants ignored the buffalo skulls. They walked straight to the elephant remains and spent enormous amounts of time touching them. One case became famous. A matriarch known as Big Tuskless died of natural causes. Researchers later brought her jawbone back to camp, where dozens of other elephant jaws were laid out. Her family came through the area weeks afterward. They walked directly to her jawbone. Her 7-year-old son, Butch, stayed long after the rest of the family moved on, gently stroking his mother's bone with his trunk. He had not seen her in months. He had to walk past the bones of dozens of other elephants to find the one that belonged to her. He found it. Then there was Tahlequah. On July 24, 2018, in the waters off Victoria, British Columbia, a southern resident killer whale named J35 gave birth to a female calf. The calf, later named Tahlequah, breathed for 30 minutes and died. Tahlequah refused to let the body go. She lifted it onto her rostrum, the long flat surface in front of her blowhole, and began to swim. She swam for 17 days. She covered more than 1,600 kilometers through the Salish Sea and the inland waters of British Columbia. When she grew too tired to lift the dead body herself, other females in her pod took turns carrying it alongside her. The Center for Whale Research, which has tracked these whales for 50 years, had never recorded grieving behavior of this duration. Orcas had been seen carrying dead calves for a few hours, occasionally a few days. Tahlequah carried hers for over 2 weeks. Marine biologists watched in stunned silence as a 20-year-old orca refused, day after day, to accept that her child was gone. Then, in January 2025, another of her calves died. She lifted that one too. She carried it for 11 days. A whale that had learned what it meant to lose and had learned to carry the loss. There is now a part of the Pacific Ocean where, for a few weeks every few years, an orca remembers a child that died and refuses to put it down. And then there is Flint. In the summer of 1972, at the Gombe Stream Research Center on the eastern shore of Lake Tanganyika in Tanzania, the British primatologist Jane Goodall watched something she would later describe as one of the hardest moments of her career. The matriarch of the chimpanzee community, an old female named Flo, had finally died of old age. Flo had been one of the founding chimps of Goodall's study. She had raised Flint, her youngest son, for nearly 9 years, much longer than chimp mothers usually keep their offspring. After Flo's death, Flint did not behave the way researchers expected. He stopped eating. He stopped grooming. He lay down on the exact spot where his mother had died and did not move. He slipped into what Goodall called a state of grief depression. 3 weeks after his mother died, Flint died too, at the same place, lying in the same position. He was 8.5 years old. He had not been sick. He had simply chosen not to live without her. It was the first time in the history of primatology that anyone had documented, beyond any reasonable doubt, a chimpanzee dying of a broken heart. Goodall stayed with him until he was gone. So what is happening inside all of these animals? Why do they wait? Why do they grieve? And why does that grief sometimes kill them? The answer is the same chemistry that runs through every mammal on Earth. Oxytocin, the hormone of bonding. Cortisol, the hormone of stress. Dopamine, the hormone of reward and longing. Every mammal we have ever studied uses the same neurotransmitters to bond, to wait, to suffer when the bond is broken. When your dog hears your key in the door, its dopamine spikes the way a friend's does when they see you across a room. When you do not come back, the cortisol stays high, the body stays alert, the brain stays in a state of looking for you. The systems are identical. The pain is real. We are not, and have never been, the only species on Earth that knows what it is to wait for someone who is not coming back. For 200,000 years, you have walked out of rooms and assumed the animals inside them forgot about you the moment you were gone. The truth was always written in their bodies. The cortisol of the dog that rises when you grab your keys. The Akita that walked to a Tokyo train station for nearly a decade because the man he loved could not come home. The elephant son, who stayed by his mother's bones long after the rest of the family had moved on. The orca that carried her dead child across an entire ocean and then did it again 7 years later. The chimpanzee who lay down on the spot where his mother died and never got up. They are not background. They are not waiting for our food. They are waiting for us. And every time you walk back through your door and find your dog already there, ears up, tail moving, you are walking back into the mind of an animal that has been counting the seconds since the moment you left. We have lived our entire history believing that we are the only species in the room with a heart. We never were. They have been missing us the whole time. We just stopped paying attention to how loud the waiting actually was. Somewhere out there, in a kitchen you are not in, the head of an animal is currently tilted toward the door, waiting for the sound of your shoes on the stairs.